Hello and welcome. The demonstration today is based on the Avramenko plug. Stanislav and Konstantin Avramenko filed a patent on the 10th of May 1993. It's a straightforward application with interesting results as one-wire power transmission project demonstrating the dielectric field propagation. A radiant energy project of dielectric field propagation. I will demonstrate the static electricity is the electron provider marked as the radiant energy. The project is very simple. Two diodes as half bridge connected to one wire and to a capacitor on the opposite side in parallel with a load. In my example, the load is the 18 watt fluorescent light bulb 60 cm length. You might have seen experiments with LEDs or small xenon flash bulbs. I use a 12 volt battery and no ground connection. I also use 100 ohm on the positive battery polarity to reduce the maximum amount of power which can be delivered to between 1.7 and 1.8 watt. The capacitor on the Avramenko plug is a 2 kilovolt 200 nanofarad film capacitor. The signal generator and the CVS half bridge and drivers are provided via step-down voltage transformers. I trigger the flash of the tube via various objects which I charge statically by rubbing on it. Some theorize that stray capacitance is responsible for the flashing. We must be clear about the process. Energy potential is required to trigger the flash. Once the power is started by using a copper wire around the tube, it will flash. Once the flash did occur, it will not flash anymore unless we provide the potential difference. The potential difference we need is in form of a static charged acrylic tube, rod, nylon rod, or my hand. To continuously flash the tube, a large reservoir of static energy is required. Depending on the material we use and with what we rub on the object, it becomes either positive or negative charged. I use a polyamide 20% and polyester 80% cloth, which is normally used for dusting. Let us have a look now at the demonstration table and at my setup. So here on the table now you see a couple of things, and let me explain to you. So you see in the back you see the fluorescent light bulb, 60 cm long. It is rated 18 watt on mains power, 50 Hertz here in Europe. You see a little copper wire is wound around it on one side of the tube. So to the tube goes the Avramenko plug, which is behind it. You see only the capacitor. From the capacitor goes out the red and the black wire to each side of the end of the fluorescent bulb. So I measure, you see here is a high voltage probe. I measure the voltage which goes in. I see that on the oscilloscope, which you will see as well. We have the signal generator here in the left corner on the bottom. I measure the current with the current clamp. I tested it before also with direct connecting a DMM, and the values are correct, absolutely correct. So we have currently, as you can see here, 13.79 volt. I charge it via an isolated power supply. At the moment only at a standby at the lowest voltage setting to keep the battery refreshed. So 13.79 volt currently, and if you take 100 ohm, it is 138 milliampere. It can maximum draw. So we're going to see here on the bigger DMM, I have measure from the current clamp, I measure the current going in. So this is some information for the power consumption. So we have here, before I continue, we have here in front, you see an acrylic small tube, 10, 12, 13 centimeter long. You see here a nylon rod and I have some Christmas decoration here at the end, which can be attracted by charges, either positive or negative, from any of this object. And then we have also on the right side, next to the cloth, I have an acrylic rod. So the capacitor has 200 nanofarad and it will charge up to an RMS value of 1 kilovolt. at 1 kilovolt, it can hold at that moment 0.1 joules or 100 millijoules. So we are providing 1.7, 1.8 watt in, but the stored energy is only 100 millijoule, but this is enough to trigger a flash, to ignite a flash of the tube. However, not continuously. So the copper rod, which the copper wire, which are wrapped around, you will see when I go with these tubes on it, it will be attracted. So the whole system is electrostatic, if you want, and the voltage here in that example is peak to peak around 3 kilovolt, and it is, as I said, RMS goes up to 1 kilovolt. You can see that on the oscilloscope. So we're going to test various things in the tube and so on. Frequency does not really matter that much, I have to say. We go to various frequencies. You can see that they will all be able to be displayed. So we'll go over now to the demonstration and demonstration table, and we'll start with the experiment. So I'm now at the demonstration table, and just only a couple of things which I did not mention. Here's a 100 ohm resistor. Here is a ZVS. Yes, that you know, and we know how efficient it can be. However, the 100 ohm resistor is here only as a current means to reduce the power. However, it makes the system completely inefficient, but that is not the main concern here for that video. That's the subject I will discuss at a different time. So we have the 100 millijoule on the capacitor, and on a signal generator we have set it to 13,400 Hertz. So if I start the signal up, so you see that both signals on the system currently, and they're running quite nicely. So current probe is up 13.79 volt. It might flash now. Let's think if it works. It did flash once. So at the one starting, when this copper wire has enough charge, it takes some time. Then when I start the system, it will flash. Without the copper wire, it will not flash. So you see now currently it's 3.1 kilovolt on the oscilloscope. So what I'm going to do, I can show that, and I will later on also go closer to the tube. So I go here. This is a special kind of high voltage cloth. For those of you who don't know, I had an accident and I have in my arm a metal implemented, and that did cause me for my test here quite a lot of pain during the night. Even if the energy is very, very low, it goes through your body, even if you don't feel that. So at current settings, it might, you see, it's attracting a little bit. I will go later on. But if it triggers or not depends on how much charge is on this acrylic tube. Let's see. Not enough charge. What I'm going to do now is I rub only slightly, and here we can check, and you can see here that is attracting here. Maybe it's on the side that you can see that. Put it here. So it's attracting quite nicely. You can see that. Now this rod is charged up as well. So if I go now here with the crystal, it should normally start up. It does not. It's not enough charge. So let's go with this tube. Let's see. No. It normally should work. Let's give it a little bit more. Now it did it. So it's also pulling up. So if I touch now, it will not work because I have not built up enough charge. So this cloth is also avoiding to a certain extent electrostatic charge. However, at some level, it still is strong enough to trigger that. but at the moment it does not. So if you take this rod here, it does not. So if I rub this one, so that should be quite strong. Let's see. Yes. Kinda. Let's see if it works. The hand. It worked. But I had to touch it. Normally I don't need to touch. So we do that again. Try that here. And use it now my left hand. And you can see here how strong I attract the wire. And let's go on with the frequency a bit. Quite high actually. Normally it doesn't need to be so high. You will see currently 118 milliampere, so this volt is equal to milliampere. It's reading from the clamp. Try it again. Now it did it. Now let's go down a little bit in the voltage. Let's in the frequency. Sorry. So here it's not so high. You see we have 124 milliampere current flow. So let's try this one now. See if we can see that. Let's do it like that. No. Now you go up in the frequency a bit. 13.5 kilohertz. Let's see if this works now. No. Rod. So it was my other test. I could do it all the time. You see how strong it gets attracted. And as you can see here, I was in this distance and it did start. You see how strong it gets attracted from the rod. Let's do that again. So this is a reservoir of starch energy I'm talking about. If you want to continuously have it flashed, you need to have it at least 50 times flashed by the second. That would be then like a continuous illumination, and then it would be very, very efficient. So that's a different subject we need to look at. But for this load, for example, do it again. You see, I was at that distance. That's about two and a half centimeters, and it was enough to trigger. Do it again. Should be high enough. Of course, if I touch, it just did it. So what object to use, how to store the stored energy. There are different kind of applications which have been done. When we talk about radiant energy, it's always marked as radiant energy, but technically it's stored electrostatic energy. We have currently a humidity of 51% in the room. It is not ideal. Also, it depends a bit of the daytime. Yesterday, it was flashing continuously when I did some experiments. It had actually a hard time to get it not flashing. However, now during the day here, weather has a bit changed. Let's see that. It did it as well. It was about 1 centimeter difference, a distance of 1 centimeter. Can I do it again? The charge is now almost gone here. It might not work at all. Let's see. No, I can touch it. As you can see here, I have no charge on it anymore. I cannot trigger the flash. I have to rub it. And that's what you need to be aware of. You need to provide extra charge in order to trigger that. But that's only for this load. Yeah. But if you have other kind of ways to energize or store energy, you need to think about the same will. You need to have potential differences. Let's do that again. It's not charged. It's not attracting very much, the copper wire. So I have to rub it a bit more. Let's do it with my right hand now. See if you can see that. I'm not touching. So it was about 1 centimeter distance. So I will zoom in a little bit now to arrange it so that you can see this part of it much more clearly. So I have now zoomed in only on the copper wire. And I want to see if my hand now of this, if I can trigger the flash now only with this huge gloves. These are actually the strongest one you can buy. They are normally used for the high wire power line workers. This one can handle 80,000 volt, and there's an additional glove, a lesser glove which comes on top. So 80,000 volt. But these gloves, they have an expiration time because they fall apart. They can't last longer than 2 years, and then you have to buy new ones because it's natural. It's natural caoutchouc. So let's see if I can trigger it with my hand. Yes. So even with my hand, I can trigger it. Can I trigger it again? No. Because now my charge is gone here on this hand. So I would have to do that again. I'm not sure if I have enough charge on this tube. Yes, I have it. Let's see if I can trigger it with a... Can you see that the copper wire is moving? And it did flash. Now let's do that here in details now with a... See if I can do that. I rub it a bit. And then I want to show you how it attracts. Let's see that. You can see that. Not much. See the other side. See if you can see that. This one is really strong. Should be able to see that, yes. Look how much movement I can generate on this wire. And here you go. Try with a rod. It's attracting also quite nicely. See that how much I can trigger the wire with the electrostatic charge here. At that moment, electrons are flowing. If I go closer, so I'm really attracting it like a magnet. And here you go. We can continue this in various variations, but that should give you a good idea about what it is all about with this one-wire power transmission. So the task here, so that is a very, very good experiment. I recommend everybody to start doing that. I wouldn't use high voltage power supplies, a flyback transformer. They're ideal to use for such kind of projects, and try to use as little as power. I don't think that you require a battery. I think that with a power supply would work as well. However, a negative charge or grounding this wire to earth, and it will not work. I have done that. If you ground this wire, it will not work. So you can't have grounding on there. You need an electrostatic charge. And that is something else. How can we produce a large reservoir of an electrostatic charge? there are kind of systems existing, there are kind of applications existing, and that's something I will investigate for my members on my website, because I'm currently working on dielectric field propagation in a different subject with a LMD network. However, this is part of the same subject, and we have done such experiments, and everybody has done such experiments in the past. We know metal is attracted under high voltage static electricity. Tesla systems, they all have proven that that is the case, and that is also always an indication for electrostatic energy. So thank you very much for watching. Hope you join me on my website. Until the next time. Goodbye.